So in chapter 2, what we're doing is we're going to be describing distributions with numbers, specifically measures of central tendency and measures of variation. So in this chapter, we're going to cover the measures of center, which are mean, median, and mode. We're going to learn how to compare the mean and the median and when to use each one. We want to look at variability within the quartiles. Quartiles break our data set up into quarters. We're going to use those quartiles along with the min and the maximum to create a 5-number summary, which we can express using a box plot, so another type of graph for quantitative data. We're going to learn how to spot outliers and use a modified box plot to eliminate or kind of ignore the outliers a little bit more. We're going to practice measuring variability by calculating the standard deviation. I'm going to show you how to do this by hand, but then after that, you can use statistical software. We're going to talk about choosing measures of center and variability, go over some examples of technology, and lastly, organize a statistical problem. So a great place to start is, what is average? What does it mean to be average? I think a good example of this is height, right? If we were to think of average height, maybe it's like 5'8", 5'9", 5'10", right? Our average falls towards like the center, right? There are some people who are quite a bit shorter, and there are some people, like some of my NCAA basketball students, who are quite a bit higher. But on average, it falls towards the center. It falls towards the middle values. And that's why we call average or mean a measure of central tendency, because everything kind of tries to normalize, goes towards the center. So we have 3 measures of central tendency: mean, median, and mode. Mean is most typically called the average value. I may have said that before. And to calculate that in not so mathy symbols, what we do is we take the sum of all of our values divided by the total number of values in our data set. So if I wanted to find the mean age of this class, I would add up everyone's age and then divide that by the total number of people in our class. The median is the middle value in the sorted data set. Sorted mean I arrange it from smallest to largest, right? And we're finding the exact middle value. And then mode is the most commonly occurring value in a data set. So if I was thinking about this class is typically taught to freshmen, but we are in the summer semester, so you're probably not 18. I bet you the mode would probably be like 19, right? So I do have a nice little jingle to help us remember the differences between mean, median, and mode. Now, I am not a musical prodigy by any means, but it goes to the tune of row, row, row your boat. So it's mode, mode, mode the most, the average is the mean, median, 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 the number in between. So there's a little Easter egg for those of you who actually listen to these videos. Thanks. So let's work through an example. I want us to find the mean, median, and mode. So I have 8 grocery stores who sell the PR energy bar for the following prices. So our unit is money. It's important to remember that. And we're going to find our mean, median, and mode. So the mean, what I want to do, sometimes we call that X hat when we're being more mathy. I have to take the sum of all of these data values. So I'm going to write these all out. And now you can do this in R. It will do it for you, but I want to show you how to do it by hand. So I take all these data values and I divide them by the total number I have, which in this case is 8. And I find a mean of 1.41. Now it's important to remember that that's money. I know I kind of left off the dollar signs here, but it's always important to remember what our unit is. Next, let's calculate the median, which we typically denote with a capital M. In order to do that, I need to sort this data set from smallest to largest. So what I like to do, again, leaving off the dollar signs because I know and they make things messy, is cross off my items as I copy down the data values, so nothing's accidentally double counted, and so nothing is missed. I think it's really important to make sure that all data is represented. So I have my data set, and the median is the middle value. Well, I've got 8, right? There's no exact middle value, right? Here I divide my data into a lower half and an upper half. So what we're going to do is we're actually going to take the 2 middle values and calculate their average in order to find our median. That gives me, divided by 2, that gives me $1.37, right? Which is pretty close to our mean, but not exactly the same, which is to be typically expected. Next, we have our mode. It's important to note that not all data sets have a mode. You don't necessarily have to have a mode. If this value of 1.29 was excluded, right, then I wouldn't have a mode, but luckily it is included. So I have a mode of 1.29 because that value occurs twice. Now notice our mean, median, mode, they're not all equal, but they're kind of close together. And keep that in mind as we go through this course. Why are they different? Why aren't they the same? When would they be the same? These are really important to ask ourselves these questions as budding mathematicians. So here's our second example. So graduating seniors on a men's basketball team receive the following first-year contract offers to play in the National Basketball Association, or NBA. And I teach a lot of college algebra, I teach a lot of stats, so I get to see a decent amount of our NCAA basketball players at SLU. And I now have at least one student that I know of that's in the NBA, so an outlier, but pretty cool. So let's look at this data set. I got 0, zil, zilch, bupkis, $10 million. Do we think the mean would be a good portrayal of what contract offers our students receive typically? Well, our mean in this case would be 0 plus 0 plus 0 plus 0 plus 10 mil divided by 5, which gives you a cool 2 mil, which is nothing to shake a stick at. But that's really different than our median, which in this case would be 0, and our mode, which in this case would also be 0, right? $10 million is very far away from our norm, and so for this, we would call this an outlier, right? An outlier in a data set is a value that's much higher or much lower than almost all the others, and tends to skew with our mean, but it doesn't affect our median and our mode. So we've talked about the mean already. The most common way to measure center is the mean. It's called the arithmetic average or mean. As I said, we denote that X bar. And what we do is we take the number of observations we have and we divide them by the total number of data values in our data set. We could also write this as 1 over n, that's the same thing as dividing by n, as the sum, this here means sum, this capital sigma, of all of our data values. And that's how we calculate our mean in a little more mathy notation than I'd showed us earlier. Another measure of center is our median. We like this because the mean cannot resist the influence of outliers, right? We have to add everything together, as we saw in example 2. But the median is resistant to outliers. So our median, capital M, that's the middle of our distribution, right? As I'd said earlier, it does mark the 50th percentile. So to find our median, we need to sort our data. We need to arrange it from smallest to largest. If the number of observation is odd, our M, medium, is the middle value in our observed list, right? We saw that in example 2. If we have an even number of observations, what we do is take the average of the 2 most center observations. We saw that in example 1. And you can always locate the median in an ordered list of observations by counting up n plus 1 divided by 2 observations from the start of a list, but sometimes you'll get a fraction. You've been warned. So let's go through another example of measuring center. So let's use the data below to calculate the mean and median of the commuting times of 15 randomly selected North Carolina workers. Now, of all the workers in North Carolina, this is a really small data set. So to calculate the mean, what I'm going to do is I'm going to add up all of their commute times and divide that by our sample size n, and I get a mean of 25.3 minutes. So that would be our mean. Next, I want to calculate the mode. One way to start this might be to organize my data and write them out as a whole list, or I could make them into a stem and leaf plot. I've got 15 data values. So my middle value is going to be 8, right? That would leave me 7 on each side. I could have taken n plus 1 divided by 2, which would tell me 8, but if I wasn't certain. So I count 1, 2, knowing that this is not part of my data value, right? It's just the stem. 3, 4, 5, 6, 7, 8, right? And we know how to interpret this. So this right here is my median. That means my median is 20 minutes. So that's pretty close to my mean, but not quite. So when we compare our mean and our median, the mean and the median measure center in different ways, but both are really useful, right? If we have a roughly symmetric distribution, so it's like pretty close to being symmetric, right? They're gonna be close together. If I have an exactly symmetric, so like a perfect distribution, like a normal distribution or a bell curve, the mean and the median are exactly the same. In this case, the mean would equal the median would equal the mode, which is really nice and very convenient. In a skewed distribution, because we typically have outliers that are pulling our mean further away from our median, which we'll discuss more in chapter 3, our mean is usually farther out along the long tail than it is the median, right? Those outliers, oh, that looks pretty normal. Let me try again. Let's try and make a not a normal distribution, right? Okay, that kind of worked. Darn it. Okay, so if I've got like my median here, my mean is affected by these outliers and is going to be, further out. Maybe not this far, but pretty far out. So here I have a nice table discussing and comparing the mean, median, mode, right? The mean always exists, so does the median, but there could be no mode, there could be multiple modes. The mean we like because it does take every data value into account, while the median and the mode do not. But the downside, the mean is it's affected by outliers, while the median and the mode are not. So this table is not in our book. I actually got it from another text, but I wanted to make sure I shared it with you.